Now we will continue one more video, that is applications of equilibrium constant. Applications of equilibrium constant. There are two applications are there. That is here. The knowledge of equilibrium constant help us. The knowledge of equilibrium constant help us in predicting extent of the reaction. How much reaction is extent of prediction of extent of the reaction, and as well as a direction of the net reaction. Predicting the extent of reaction, predicting the direction of the reaction. The first one is predicting extent of the reaction. Predicting of extent of reaction. What is predicting of extent of reaction, sir? Actually, okay, now I am taking, this is one chemical reaction. What is this one? Chemical reaction. Or simply to take here, now I am taking arrow mark. This arrow mark which indicates direction of the reaction. Okay, now this is one chemical reaction. Okay, the range of equilibrium constant, you can observe here. Now I am taking in this part. This is the equilibrium constant or chemical equilibrium here in this part. Equilibrium constant K. The range of equilibrium constant between 10 to the power of minus 3 to 10 to the power 3 means 1 by 1000 to 1000. The range of this one 10 to the power of minus 3 to 10 to the power 3 only. Now this part, this is called reactant. This part is called reactant. Remaining this part is called product. Okay, here hardly reaction is going. Reactant is going. Hardly. The reaction is going hardly. The reaction hardly going. Reaction is going on. The reaction is going on hardly. Means reactants are initial concentration of reactant is more, then the reactants are slowly combined, then we convert it into product. Okay, next here you can observe it is almost a large extent of the reaction. Up to in product side, almost reaction is completed. Almost large extension. Almost large extension of reaction. Almost extension of reaction is completed. Simply. You can observe in this diagram. There are three types of conditions are there. First one is case equilibrium constant value is greater than 10 to the power of 10 to the power 3. Means if Kc value is more than 1000, then what happens are here? Products predominant. Products are more form. Means the reaction is completely takes place. Okay, simply, if the Kc equilibrium constant is higher than or greater than that 10 to the power of 3, product predominates. Products predominates over the reactants. Means more products are This is first condition. If you take second condition here, if Kc is case here you can observe case number 2. Kc is less than 10 to the power of minus 3. Now what happens, sir? reactants are predominant over the product here. Reactants predominant over product. Okay, one more condition, third one is here. You can observe if Kc value is equal between 10 to the power of minus 3 to 10 to the power of 3, then the equation at equilibrium condition. Then the reaction at equilibrium. Okay, this is information about the predictant of the reaction. Once again repeat here. Listen carefully. That is first one is predicting the extent of the reaction. The magnitude of the equilibrium constant gives an idea of relative amounts of reactants and products. That is Kc is greater than 1 or 10 to the power 3 products predominant over the reactant. Kc is less than 10 to the power minus 3 reactants predominant over the product. If the Kc is equal to between 10 to the power of minus 3 to 10 to the power of 3, equilibrium position. Okay, this is the first factor. You take one more factor, that is application, not factor, application. Second application is prediction of direction of the reaction. Direction. Second application, predicting the direction of the reaction. Direction of reaction. For example, now I am taking here general form. Small a plus small a capital A, small b capital B, small c capital C, small d capital. It is one general equation. Here Kc is equal to the ratio between product of concentration of product to the product of concentration of reactant with each concentration term raised with some power. You can observe here, from the knowledge of equilibrium constant, it is possible to predict the direction in which the net reaction takes place at a given concentration or partial pressure of reactants and product. At each point of the reaction, each point of it is up to only equilibrium. Kc, which indicates at equilibrium position only. Each point of the reaction, we can use one more term, that is reaction quotient. What is the term? Reaction quotient. Okay, reaction quotient is denoted by symbol Qc. Same this value also same. C power C, capital D power D, capital A power small a, capital B power B. But at equilibrium condition Kc, at each point of the reaction we can use the reaction quotient. The reaction quotient is useful in predicting the direction of reaction by comparing the value of K, Q and as well as Qc. Now I am taking here, you can observe there are same three conditions are there. Case number 1, if you take Qc is less than Kc, what happens, sir? First one, Qc less than Kc means here the net reaction takes place forward direction. The net reaction Kc is more. For example, if you take here diagram, this is if you take this is Qc, this is Kc. Qc is less than Kc. The reaction is the predominant always forward direction. Means the reaction proceeds from left to right only. Second one, if you take Qc is greater than Kc, what happens, sir? Means this is Qc, this is Kc. The reaction takes place backward direction. That is the reaction proceeds from product to reactant. That is the backward direction. In case if you take one more here, one more condition, third one, both are becomes equal, Qc and Kc, both are becomes equal, that is the equilibrium position. Okay, there are three conditions are there in predicting the direction of the reaction. If Qc is less than Kc, the reaction, the net reaction takes place in forward direction. If QC is greater than KC, the net reaction takes place backward direction. If QC becomes equal to KC, that is equilibrium condition. Okay, this is information about what are the applications of equilibrium constant. Thank you.